So is the screen visible?
Yes, sir.
Yeah. So about iota we discussed. We were basically iota x square root of minus. When we'll come to solve for the value of 1 raised to power 1 by 3, then there will be 3 roots of for this value, for this x. What is this equation? X cube is equals to 1. So there will be 3 roots for x here. One is 1, another one is omega, another one is omega square. These are known as cube roots of unity.
Okay.
There also an omega is used. And also, as you were speaking that in angular frequency, we are aware about this term. So this is basically theta per time, when time get multiplied. So remaining is the radian theta. Understood?
Yes, sir.
Yeah, this is used like sine omega t plus cos omega t, those kind of equations. Anyways, moving ahead. Now this is a very important concept to note down about this. Whenever there is whenever there is something like this x raised to power n plus y raised to power n, and if n is given as an odd number, odd natural number, okay, then this xn plus y raised to power n will be divisible by x plus y. And if a if x raised to power n minus y raised to power n is that, if it is given like this, okay, then and n is like any natural number, then it will be for damn sure divisible by x minus y. And if n is given as particularly even number, then it will be divisible by both x minus y and as well as x plus y. Then it will be divisible by x square minus y square. And if n is a natural number, we can also understand it if there is x raised to power n minus y raised to power n, simple, n is an integer, then definitely it will be divisible by x. It will be divisible by x minus y, simple. N is a natural number which includes both odd and even. And if particularly given that n is an even number, then it will be divisible by this x raised to power n minus y raised to power n. This will be divisible by both x raised to power minus y, sorry, x minus y into, and also x plus y. So I have written it like this. Otherwise, you can also write it like this, that it is that this particular given term, given expression will be divisible by x minus y and as well as x plus y. Understood?
Yes, sir.
Let's take an example. Um, like page. So it was given as that if n is a natural number, then it will be divisible by speak x minus 1. So let's take an example. So the example is that it is given 2 raised to power n minus 5 raised to power n is, let me write it in different way. 10 raised to power n and 5 raised to power n Now we have to check is divisible by A option is 15, B option is 2, C option is 5, and D option is none of the above. Okay. So tell me, and also it is given that n is a natural number. It's not specified whether the n is odd or even. So it is in the same terms. So x raised to power n minus y raised to power n is the given term. N is a natural number. Okay. So it will be divisible by x minus y, which is 10 minus 5. So 10 minus 5 is option number C. Correct? Understood?
Yes, sir.
This is how this property will work. And if n is even number, then it will be divisible by x minus y. Yes, of course. And also it will be divisible by x plus y. So let's understand that this was the first part of the question. Let's assume that this was the first part of the question. These are the options. There's another part of the question where it says that n is even number. And now the options are 15 and 2. B option are 2 and 5. C option are 5 and 15. And D option is none of the above. So which answer is correct now? This is the same statement which we need to find out that this is the given statement. It's now we have to tell about whether it is divisible by 15 and 2, 2 or 5, or 5 or 15, given that the n here is even number. Any guesses? Please guess. No problem.
2 and 5. Option B, sir.
No.
No. Okay.
It will be divisible by x plus y, which is 10 plus 5, and also 10 minus 5,
Minus 5.
which is 5. So 15 and 5 से divisible होगा, which is option number C. Correct?
C. Yes, sir.
Yeah, that's how these property will work. Understood?
Yes, sir.
Another property, and n is given as odd number, only true for odd number. Okay, then it will be divisible by x plus y. Let's take an example. N is given as odd number, or also, and whether we need to find out is divisible by option number A 1, B option number -1, C option number 5, D not. Now tell me the correct answer. Focus on this.
Option C, sir.
Yes, correct. X plus y से divisible, this will be divisible by x plus y. So here 2 plus 3 will be divisible by 5. Correct? So let's take one more example.
Yes.
What's the correct answer?
Option C.
Yes, right. Very good. So I hope it is clear.
Yes, sir.
Great. So let's discuss about some pattern of question, and let's say it is like this, the infinity loop. Okay, now how we will solve it? Do you know?
No, sir.
Yeah, simple. If we come to understand it, this is a loop going on, and why is this? And if we observe, this is also why, right?
Yes,
If you're not able to observe it, let me write it differently. So on squaring both sides, what will happen? Y square and the square root will go on plus 2 square root of 2 plus, no, let me write it in this manner. Copy paste. Copy paste doesn't work here. So simply my point is that whatever like 2, the square root is gone here. Now whatever is remaining. So this is, if we observe this term, this is particularly y, right? This is y.
Yes, sir.
Yeah. So now this is a quadratic equation. This is a quadratic equation. Yeah. We'll understand, learn how to find out the roots of quadratic equation. You also must be knowing about the factorization method. Do you?
Yes, sir.
And also Sridharacharya formula. Do you?
No, sir.
That simply x is equals to minus b plus minus square root of d upon 2a.
Okay, that one. Yes, sir. Yes, sir. Discriminant. We used to say like that.
Yeah.
Ah,
Clear? How we will solve it?
yes, sir.
If we have gone on to think about more of this question without analyzing and observing it, without playing with it, we would have been just thinking for hours. Okay. So we have to observe a question correctly and analyze a question. And if there is some intuition coming inside you, then try that out. And otherwise, if you're completely blank, drop. Okay. Drop that question in exam because it's an option. You only have to attempt 80 questions out of 120. I repetitively say this because do not need to satisfy your ego every time because there is limited time. So 80 questions are enough. So you have to draw 40 questions for attempting 80 questions. So be very, very selective while answering questions. That will help you to not waste your time. Understood?
Yes, sir.
Okay. So now let's go back to what we were studying yesterday, divisibility rule. So I think that's enough for us because that's only important to that study that much only in divisibility rule. Okay, any doubts in divisibility rule?
No, sir.
Okay. Now let's discuss about LCM and HCF. So please tell me the full form.
Least LCM least common multiple, HCF highest common factor.
Correct, right. So before that, let me just briefly tell about remainder theorem. So whenever we divide, whatever we write here is dividend. And you can like remember I used to get confused between uh, divisor and dividend. So I learned it that dividend spelling is big. That so the bigger one is comes under the like these two brackets. Okay, and the smaller the D's term, which is having smaller spelling, will be outside. That's how you can remember it if you have no difficulty like me. And whatever will solve, whatever will be remaining will be known as remainder. Okay. So understood?
Yes, sir.
So we solve this. So 2 is what?
2
2,
is the divisor, sir.
yeah. 9 is what?
Dividend.
1 is what?
Remainder.
What is this?
Quotient.
What is this? Even I don't know that. Let's leave that. So dividend can be written as divisor into quotient plus remainder. In this case, 9 is the dividend, 2 is the divisor, quotient 4 plus remainder is 1. So is it satisfying?
Yes, sir.
Yeah. So you need to remember this thing of this particular very basic formula property. Dividend is equals to divisor into quotient plus remainder. And also there's one more thing that remainder can be of two types. Can either be positive or it can be negative. How? But mostly whenever we have to find out remainder in questions, we consider the positive value. But sometimes it can be also find out negatively. Like 9 is there. So instead of multiplying it by 4 and writing 8 here, you can multiply it by 10, 5, write 10 here. When we will get subtracted, then the remainder will come out as a negative minus 5. Then still this condition will satisfy 9. Divisor into quotient minus of 1. So still it is satisfying, right?
Yes, sir.
Yeah. So remainder can be negative also, but whenever we have to find out officially and formally the remainder, so we need to remember one thing, that the remainder which is positive and the remainder which is coming out as negative, those sum always will always be equal to the divisor. In this case, when the positive remainder was 1. Modulus of minus 1, the negative modulus means that whatever the value is inside, its magnitude to magnitude will come out and the sign will remain positive, whatever the sign inside it is. Okay. So 1 plus 1, it will be 2, which is our divisor, right? Understood?
Yes, sir.
Yeah. So these are two important basic properties. Remember them. That's it only. That's that much is only important for us. Okay.
Yes.
And so let's say you have to find out about the products remainder when it is divided by 7. So there's a basic knowledge, basic thing. The remainder of 2 by 7 will be what? When we will divide 2 by 7. So what will be the remainder? Will it get divided further?
Actually, it will be in decimals.
So when we will find it in decimals, then still we cannot find the remainder there, because if we are finding in decimals, so what's the use of remainder there? In decimals, we solve only to get the remainder as 0. So like let's discuss about this case 2, 4, 8, 1. So why we didn't solve further ahead of 1? Why? Because here we didn't had any other figure to get down it. Otherwise, we have to take a decimal, and which will not be having our like we are solving for mixed fraction here. It will be written as this. So here in this case, we do not find for decimals. We do not solve for decimals. And why we stopped here? Because 1 is smaller than 2, right? So it is the same case here. 2 is smaller than 7. 2 is itself the remainder. So what is the dividend here? 2. What is the question here? 0, right? What was the remainder here? 2.
2.
So is it satisfying?
Yes, sir.
Yeah. The question is 0. The divisor. No, sorry. Yes. No. Yes. Yes. It is divisor, and this is dividend, and this is our remainder. Okay. So now let's apply the same Guthi, same logic, same analogy on our bigger sum. We'll be able to find out it is. So now 47 can be written as 49 minus 2. And we are doing it purposefully. I'll tell you why. Just for understanding. Okay. 7. So 49 is a multiple of 7, right?
Yes, sir.
35 is a multiple of 7.
Sir.
So if we will divide them by 7, what will be the remainder?
0.
Yes. And we will divide 2 by 7, what will be the remainder? We just now we have discussed. What will be the remainder? We will divide 2 by 7.
We don't like. It will be 2 only, sir.
Yes, it will be 2 only. And what if we'll divide 35 by 7? What will be the
5.
remainder?
5.
Remainder, not question.
Oh, you're asking for remainder.
Yeah.
0, 0.
What will be the remainder when we'll divide 1 by
1.
7? Yes. So now remainder is minus 2 into plus 1. So our remainder will be minus 2. Can it further get divided by 7? Can 2 be further divided by 7?
No, it just comes in decimal again.
No. So our remainder is minus 2 only.
Yeah.
Whenever we need to find out the remainder, we need to find out in positive terms. So for finding positive remainder, we know it will be equal to what? Divisor, right?
Yes, sir.
What is divisor here?
7.
Good. So positive remainder is what we have to find out. The negative one is minus of 2
Minus
modulus plus 2, 7. Now what is positive remainder?
5.
Yes, very good. That's how we find it.
Okay.
So this much is only important for us about the divisibility rule. It's more asked in UPSC CDS. That too in IMA paper. So let's now move ahead and discuss the next concept. Next concept of LCM and HCF, which is very simple. So LCM. What is LCM?
Least common multiple.
Yeah. Lowest or least common multiple. Highest common factor. So for both of these to find out these, we need to find out the prime factorization of any number. So for finding prime factorization, we simply do one thing that we write the number. Let's take the number as 128. Or let's take something else, something more hard. Could you suggest some number? Any number?
Any number of digits.
Hmm?
Then 100 or yeah, 100, 120.
Yeah, 120. So,
Yeah.
so what we'll do, we'll start with the lowest prime number. We'll check whether the lowest prime number can divide it or not. What is the lowest prime number?
2,
Yes. The next prime number?
3,
The next prime number?
5,
The next prime number?
7,
The next prime number?
11,
The next prime number?
13.
Yeah, enough. So whether 2 can divide it or not?
Yeah, sir.
Now 2 can divide it or not?
No, sir.
Why?
It's not a multiple of 2.
Yeah, this is an odd number.
Yeah.
So whether 3 can divide it or not?
Yes, sir.
Now 3 cannot, 5 will. So this is the prime factorization. And how we will write it? 120 into 2. How
2
many
in
times 2 is coming?
3 times.
3 to 5 into 1. Okay, so this is about 120. Let's take another number. 144. So 272, 236, 218, 293, 331. So 144, 2, it's coming 4 times. And 3 is coming 2 times into 1. So now what we'll do for finding LCM, okay, for finding LCM, that is the lowest common multiple, we are going to pair numbers, pair the factors. So 2 raised to power 3, let's write it in separate forms. Let's write in an expanded form like 2 into 2 into 2 into 3 into 5 into 1. And this has 2 into 2 into 2 into 2 into 2 into 3 into 3 into 1. Understood how we have written so?
Yeah, sir.
Yeah, we make pairs of common factors 3 and 3, and there is no 5 here. So for finding LCM, we'll take the from the common pair, we'll take only one number out of it. So from two twos, we'll take 1 2 from the pair. From two twos, we'll take one pair only in like this. The remaining, all the numbers which are there, they will be written as same from the first 2 into 3 into 1 that is there, and here it is 5 is remaining. So this will be your LCM. Understood?
Yeah, sir.
Yeah, so what is this? 8
8 into 6, 48, 48 into 15.
15 into 6, that is 90. 90 into 8 is 720.
720.
Yeah. And what will be its HCF? For finding HCF, what we need to do is that we will only take the common pairs. Like we are finding the highest common factor. It should be the highest common factor. So most of the time LCM can be greater than HCF and they can be equal also sometimes. Okay, but most of the times LCM is greater. So we'll take 2 from the second pair, 2 from the third pair, then 3. And we'll take nothing from the remaining. We'll take only the paired. Okay, because we are finding common factor. Factors are, we also discussed about factor of like 16. 1, 2, 8, 1, 2, 4, 8, 16. And the multiples of 16 can be infinite. Right? That's why like multiples are starting from 16 itself and they're going on and on. Factors are limited and they are also equal and less than 16. So that's why also HCF will be less. 8 into 3, which is
24.
yeah. So observe this slide. Understood?
Yeah, sir.
Yeah. So now comes the real talk. Now to find out the LCM of two bigger numbers, quickly, what we'll do, like, let's say we have to find out the LCM of 16, 144, and 18. Okay, so what we are going to do is that we'll take the largest number out of these three. Take the largest number, which is 144. Now we will check. Now we'll check. Okay, we'll write its factors. So this is basically 12 into 12. So this is what? 3 into 4. So this is 3 into 4 into 3 into 4, which is 3 raised to power 2 and 2 raised to power 2, which is coming twice. 2 raised to power 4 into 1. So this is prime factorization of 144. Okay. Now we'll understand whether these factors can include the others or not. And if so, if they can include the others numbers, so the whatever the largest number is, it is the LCM. Otherwise, we will have to multiply. We'll have to multiply the factors, the other primes, to make this include other numbers too. And the result will be the LCM. In this case, whether 16 is here or not, so 2 raised to power 4 is 16. So 16 is here already. Understood? In this factor, we have to find 16. So 2 raised to power 4 is 16. We found it, right? Are you with me? Understood or not? Should I repeat?
Yes, sir.
Should I repeat?
No, understood, sir.
Yeah. Now let's check about the 18, whether the 18 is present in these factors or not. So 3 raised to power 2 is 9. We need to find one more 2, and which is also there. We can take 2 from here. So it will make it 18. So 18 is also here. So the LCM of these three numbers will be 144 itself. Otherwise, let's say if there is 7 also, okay, then still we'll find out the prime factorization of the biggest number, 144, which is there. Now we have found out 16 here, 18 here, but there is no 7 here. Okay. So in this case, what we needed to do, we needed to multiply 7 on both sides. And now let's find out 16 is there. Yes, 16 is there. 18 is there. Yes, 9 into 2, 18 is there. 7 is there. Yes, 7 is there. So 144 into 7 will be your answer, will be the LCM. Got it? Understood? Should I give one more example? One more example needed or not? Let me give it. So now we have to find out the LCM of 81, 27, 36. So what is the biggest number in out of these three numbers? It is 81. So writing the prime factorization of 81 is 3 raised to power 4. 9 into 9 do what? So this is the prime factorization of 81. Now let's try finding out 27 in it. So 27 is 3 raised to power 3. So it is there. 27 is there. Now let's try to find out 36. 36 is basically 9 into 4. That is 2 raised to power 2 into 2. 9 into 4. 3 raised to power 2 is there. Yes, but 2 raised to power 2 is not there. Let's multiply 2 raised to power 2 on both sides. And now 27 is there, and as well as 36 is also there. So now the LCM will be 81 into 4, which is 324 will be the LCM. Understood?
Yes, sir.
This is how we will find LCM fastly. Got it?
Yes, sir.
Yeah, so let's now talk about HCF, highest common factor. The HCF is already very easy to find out. Take the prime factorization of whole, and whatever is common, you'll be able to find out after pairing it. If there are like three numbers also, then prime factorize those three numbers and find out the common factors and multiply those common factors, taking one out of pair only or the triplet only. Taking one number out of the triplet or the pair and multiply all of them, then that will be our HCF. Correct? Understood? Understood or not? Well, basically, it's the same method, prime factorization method. There's no simple method to find out HCF in my awareness. Like if you have to find out the LCM of let's say 24, 32, and 144. So its prime factorization will be 24 is 4 into 6. That can be written as 8 into 3. So 2 raised to power 3 into 3 raised to power 1, 2 raised to power 5, and this is 12 into 12, which can be further written as 2 raised to power this 32, 16 into 8. No, 12 into 12, 3, 4 into 3, 4. 3, 4 square. So 3 square into 4 square will be 2 raised to power 4. So this is the prime factorization of this. So take the common terms. 2 raised to power 3, 2 raised to power 3, 2 raised to power 3 is common. And nothing else is common in all these. So this will be the HCF, which is 8. Understood? Clear or not? This can be written as 2 raised to power 3 into 2 raised to power 2. This can be written as 2 raised to power 3 into 2 raised to power 1. Now this term is only common amongst all. Now understood? Please respond. Yeah, I guess there is an internet issue from your side. Let's move on from LCM and HCF. Now let's come on to some basic thing about LCM and HCF, which is that if we are finding out the LCM and HCF of two given numbers, not the thing, two numbers, then the LCM of these two and the HCF will be equal to, if the two numbers are first and second, so it will be equal to the product of those two numbers. LCM into HCF will be the product of these two numbers. Understood? There's one more thing to note. The HCF of even numbers will be even, and the HCF of two, we also discussed this earlier, HCF of two co-prime numbers is 1. Understood all these points?
Yes, sir.
Yeah. Where were you? Internet broke down.
Sir, like it's raining here, so the connection is not good at all.
Okay. So this is about LCM and HCF. Let's look at the PDF. What is they have to? Yeah. If we have to find out the LCM of fractions, like of A by B, P by Q, and L by M, then what we'll do, we'll take the LCM of these numerator terms, APL, and we'll divide it by the HCF of B, Q, and M. Okay? Simply, let's take an example. If we have to find out the LCM of 1 by 2, 2 by 3, or 4 by 5, then what we'll do, we'll take the LCM of 1, 2, and 4, and we'll divide it by the HCF of 2, 3, and 5. So this is one example of it. Understood?
Yeah, sir.
This is important. And for HCF, it's same. HCF of APL and LCM of BQM. So HCF is upside in the numerator side in this condition right now. Okay. Understood?
Yeah, sir.
LCM of rational and irrational numbers is not defined. Want to be noted. So now we already discussed about remainder theorem. Let's discuss about these identities which you already are aware of. But let me tell you one thing. Okay, that in mathematics, nice. So in mathematics, formulas and identities are our tools. They are our tools. So you just not need to know how to use that tool. You must be aware that when you are going out in the workshop, what tools do you have in the toolkit, which is logged inside, which you cannot go again and again and open it and watch it. Okay? So you need to be know your tools very, very deeply by your heart. So please heed my point that you need to learn your formulas, properties, and concepts really well in mathematics. Then only when you will see questions like this, if something of this order, if it is written in front of you, then you'll be able to recall, oh, I have studied a property, and that will be used here. If you have not revised the property, revise your notes, revise your formulas, properties, concepts, or your short notes again and again, the property will not be handy to you. It will be in your mind, but you will not be able to find it in quicker method. So please just say, like, there are hard disk in laptop, there is solid state drive in laptop. So SSD works slow, SSD works fast. So for bringing the formulas, concepts into your SSD, that so that your memory is fastly you can remember them. So you have to revise multiple times. And you have to revise it by writing again and again. Again and again. Okay. So need to focus on this very much. That please make a short notebook, like I call it flash notes, and you may call it anything, but the concept is one chapter is covered in 2, 3, 4, or hardly 5 pages if the chapter is big. And all important, not important. Everything thing, every concept, every formula, every property will be written in this chapter notes, except examples. They are not important. We feel examples are also important. Some examples are, so you can include them. But my point is, you have to cover every concept, formula, or property, like whatever there is in the chapter, except the examples. Write them all in a crisp manner and revise them again and again. Okay, any doubts?
No, sir. No doubt, sir.
Yeah, so please take a snapshot, or you must be also have already have written these properties already in your notebooks. So this a plus b whole square, a square plus 2ab plus b square, and it can also be written as a minus b square plus 4ab, because when expanded, a square minus b, sorry, a square plus b square minus 2ab plus 4ab, then it will make it as plus 2ab only. Okay, that's why we have written it in this format. Understood?
Yes, sir.
Same goes for the lower property. Now, coming to a square minus b square property, this is also very important. Every property is important here. So a plus b cube, a minus b cube, a cube plus b cube. This one is more important. This is also, yeah, this is also important. This is also important. Both are important. Same goes for this. This is basically, this property is just another manifestation of this. What's typically have to remind you is this, from this method, from that whenever a cube plus b cube is there in front of you, maybe you should be able to recall that a plus b into a square plus b square minus ab. And here also can write in this format. Further, this is important. Why I'm saying this is important? Because we sometimes think, okay, these are very important. We have learned them. That's why I'm saying that all are important. All are important. And this is very much used in questions, this property particularly.
Okay.
And this is a condition if a plus b plus c is equals to 0. So it will happen that a cube plus b cube minus 3abc becomes 0, and minus 3abc goes to the right hand side. This property holds true. Okay.
Yes, sir.
Yeah, a4 minus b4 can be written as a square minus b square. Further can be written as a square plus b square into a square minus b square. A square can be minus b square can be written as like this. Okay. Okay.
Yes, sir.
Yeah, same goes for this property. So you have to back understand it from here. What is there? A plus b, a minus b. So no, sorry. It is like this. Yeah, separated it. It is like this. A square plus, what is happening is here, a square plus 1 and a square plus 1 minus, let's consider a square plus 1 as a. Sorry, let's take it as x, and a as y. So what is happening here is x plus y into x minus of y, because a is negative here, right? So here they have written x square minus y square. X is what? A square plus 1. Y is what? A. Then they have further gone on and solved this for this, which is basically y raised to power 4 plus x. Understood?
Yes, sir.
Yeah. These are some short forms. Remember them. Now, there's one more concept remaining. I will like to cover it. And the indices. Basically, it's just about if A, the base, can be non-zero, should not be zero, a real or imaginary number, and M is positive integer when A raised to power M, then it means that A raised power M, it should be En here. A raised power M means the A is getting multiplied M times. Okay. This is what it means. Where A is base and M is called as index. Okay.
Yes.
And indices is the plural form of index. Understood?
Yes, sir.
Yes. So the first property says that A raised power and understood, and we have already mentioned that A is non-zero. A is non-zero. So A raised power 0 will always give 1. A can be anything other than 0. So if we write as 100 raised power 0 is what?
1.
Yeah. What is this?
1.
Huh?
1, sir.
Yeah.
Yeah,
Anything?
1 minus 1.
No. Repeat.
No, it's like what you have given equal to symbol there or like subtraction symbol.
Equal to. There is equal to. This is.
Okay.
Yeah. So basically anything raised to 0 will become 1. And I have also told you the reason that day. Remember? The day I have told you why 0 factorial is 1.
Yes, sir.
Anything raised to 0 is 1.
Hmm.
And remember that A should not be 0 here. Otherwise 0 raised to 0 is an indeterminate form. Understood?
Yes, sir.
So now, if anything raised to power minus of exponent, then we can write that particular term in the denominator part, and the power will get the sign will be changed oppositely. Whether it can also be written as the sign will get changed oppositively. The opposite sign will be used in the exponent power when we will take the term from numerator to denominator or denominator to numerator. The power will get negatively affected. Okay. If the power was positive, it will become negative. If the power was negative, it will become positive. Understood?
Yes, sir.
Yeah. So if there's the same base and power, if two powers are added, so they can be written in product. Okay. So there is same base, the powers are different, then they can also be added. It is both ways, bidirectional. Okay. It means that 2 raised to power 5 plus n, then it can be written as 2 raised to power 5 into 2 raised to power n. And it can later on also written as that if there is 2 raised to power 5 into 2 raised to power n, it can be written as 2 raised to power 5 plus n. Understood?
Yes, sir.
Same goes for this. If there is negative sign, the power will be divided. The power which will be having a negative sign, that will go into the denominator part. Understood?
Yes, sir.
Yeah, if power is getting multiplied, they will get simply multiplied. If there is power on power, the power will get multiplied. Let's consider this. So the power will be 2 raised to 6 here. Okay.
Yes.
What will be the answer? What will be
3
the power?
raised to the power 2.
Yes. So yes, this property is also done. Whenever the power is in like in power, if there is power in denominator, so it will be rooted power. We can also understand by this fact that is becomes a square root and it becomes a cube root. And if we write 2 here, then 2 will remain here. If we write 3 here, then 3 will remain here. Understood?
Yes, sir.
Yeah. So these are law of indices. Please learn them. Like don't cram them, just understand them. You'll be able to learn them easily. Correct? Any doubts?
No, sir.
So we've discussed enough. And about intervals also, we'll cover it in the class tomorrow, in the tomorrow's class. Okay?
Okay, sir.
Any doubts?
No doubt, sir.
Okay. Thank you.
Thank you, sir. Jai Hind.